Okay, welcome to the Physics Public Engagement Seminar, Raising STEM Aspirations, How Can We Make a Difference? I'm Ollie Moore, I'm the Outreach Programmes Manager at Oxford Physics. I don't know about you, but I am completely pumped after that holding music. I had to drop down and just give 10 press-ups. I couldn't help it. It was just a reaction. But anyway, welcome to you all. It's nice to see so many of you with us. We've got people from across the university I can see and beyond as well. So thank you for taking the time to join us. I'm pleased to say that we're joined today by Dr. Martin Archer. In a moment, I'm going to hand over to Martin, but before I do, just some quick housekeeping notices. So we are recording today's session. If you'd rather keep your video off, that's absolutely fine. But if you're proud of your face and you're happy to keep your video on, please do so. It helps keep everything more informal, more interactive, discursive, two-way, and that's what we're going for today. So running order, Martin's going to talk a bit about a lot of the exciting projects that he runs for the first part of this session, and then we will open up to Q&A. So if you've got any questions throughout the session, please just post them in the chat. We'll do our best at the end then to pull those together and then pitch them to Martin, but of course you can ask them directly himself. So we'll open up to a Q&A at the end. So to hand over to Dr. Martin Archer, recently awarded a UKRI Fellowship in Public Engagement and Space Physics at Imperial College. Martin, if you're not aware, has done a lot of work over the last decade in terms of taking research projects and working with often underserved audiences to address the issue of trying to raise STEM aspirations, which, as you'll find out throughout Martin's talk, are actually quite challenging and hard to do, especially even amongst repeat interventions. So please welcome Martin. Please clap if you can on the emojis and give him a big wave and say thank you very much to Martin. Over to you.
Well, thank you very much, Ollie, for that wonderful introduction, and thanks to the team as well, Sean and Catherine, who are helping make this seminar possible. It's great to have the invitation to talk to you. I'm just going to share my screen now, so hopefully you can see the title slide, and there won't be any more Hans Zimmer, unfortunately, but hopefully you're all pumped for the talk today. It is going to be fairly interactive. There are a few questions throughout, and actually we're going to start with one because I just want to have a sense of who do we have in the room. I have an idea that we're mostly going to be seeing probably physics, but other science researchers, but also a good number of people who are engagement professionals. And throughout this talk, actually, I'm going to be asking questions, and based on which role you feel like you fit under best, I would like you to pick the options for that particular role, because I feel like the answers might be slightly different throughout. So it's always good to get a good idea of the backgrounds of the people we have here. And I do apologize if researcher or engagement professional doesn't feel like the right fit, but they're the two boxes I chose. So Ollie, we've got the poll running.
Yeah, we've got most of the results in. I'm just going to share them now. So it's a fairly even split, slightly skewed towards engagement professionals, but I think we've got a nice mixed bag, Martin. So that's
really good. Excellent. Okay, good to know that. And remember, if you can't, which one you clicked, because we're going to be drawing on that later poll questions throughout. Okie dokie. Let's close that. So basically, this is going to be a story of 3 acts. The first one, I'm going to talk a little bit about the landscape of STEM in schools. Going to build a bit on the last seminar you had from Dr. Jen DeWitt. I'm then going to talk a little bit about engagement and how there have been approaches to involve how STEM engagement works to address some of the things that have been highlighted in the research about STEM in schools. And then I'm going to talk very briefly about one approach that I developed in my time at Queen Mary called PRiSE, Physics Research in School Environments, which has been shown to be pretty impactful. Though, we'll put it in complete context throughout this story. So that's what you've got ahead of you today. We'll start with the landscape of STEM in schools then. So, as I said, you had a fantastic introduction to Science Capital and the role of aspirations from Jen DeWitt, who's part of the Aspires team. Now, we often think about this because when in the STEM sector, we do engagement, and engagement can be anything. It can be very broad, right? Public engagement, there's so many different sectors of the public, ways of splitting the public up into different boxes that we could address. And it's quite interesting that when you look at STEM rather than other academic subjects, that we seem to have a tendency of working with school students more so than other subjects do. And that's probably provoked by, sort of government agendas to increase the number of people taking on STEM subjects further beyond post-compulsory education and into the workforce. But it's kind of interesting that focus doesn't exist so much in other subjects. But we're often doing this because we're trying to raise the aspirations and kind of feed that STEM pipeline. That is what large-scale research projects into the motivations of researchers has found. But as for instance, the Aspires research found that these aspirations are really quite complicated things to not only study, but to affect, right? They have many, many facets, and they're going to naturally evolve throughout your life. I still don't know what I want to be when I grow up, but for the time being, I'm going to be a UKRI Stephen Hawking Fellow for the next 4 years at least. Then also these aspirations are really, really tied to a person's own identity. So that, of course, is going to make them really resilient and hard to change, because we don't want to be fundamentally changing people or who they are. We just want to enable them to do what they want to do. And of course, with that comes a whole load of background factors, be they societal or literally just like who their family are and stuff like that. All of these sorts of factors kind of got built together into this concept of science capital that came out of the first part of the Aspires project, and they're on to Aspires 3 now. So this is really, really big longitudinal educational research. And they came up with this graphic on the right-hand side to give you an idea of what science capital is. So it's not only just that understanding, but it's how you think about things, what you do, who you know, all of these things that kind of really affect our identity also affect how we interact with science and what we think about it. And it does have consequences on aspirations and whether students are likely to want to continue with science. Let's actually look at that STEM pipeline a bit. And I've created a little bit of a diagram based on how I see the research, right? So the Aspires research really highlighted that this science capital really forms quite early on in a child's development or in their educational stages. So, we have the tap right here, and immediately we can be having some people getting lost out of the pipeline because they've decided that science isn't for them for whatever reason. And then as they go through their, particularly secondary education, because that's really what Aspires looked at, you look at these graphs here about some of the aspects of science capital, and they seem relatively stable, right? These numbers aren't changing a huge amount, So it seems that aspirations are somewhat stable throughout secondary education. Now, that doesn't mean we don't lose some, and there was some recent work by Julie Moot from the Aspires team that was looking that if you start off with a high science capital, you're more likely to maintain that, whereas if you're sort of at medium or low levels, it's probably more likely to go down than it is to go up. So there are things that obviously need to be done in this part of the program, but I think the end of it is quite interesting and something that hasn't really been looked into in detail just yet. It's only something I kind of realized recently when I was digging through some numbers from the Wellcome Trust's science tracker that looks in a similar way at these sort of attitudes towards science as children go through their educational journey, and then comparing that with the stats on what subjects people end up doing. Now, I've only looked at this particularly for physics, so these are physics A-level students, but you can see that, if you're doing a physics A-level, you're probably going to want to do a STEM degree, and that might be physics, but, it could be another one. But then when you look, there seems to be this drop-off in not only those that actually end up going to do physics, but also the ones that end up going to do a science or STEM subject at all. These are odds ratios of 2 to 3, which is not to be sniffed at. What is happening there? That's something I don't have the answer to, but it shows that actually we do need something at this end of the pipeline as well as early on. And we'll talk about that when we talk about sort of engagement approaches, but I just wanted to highlight some of these numbers. But that's STEM in general. And actually, it's been quite interesting to see some of the publications on attitudes to physics in particular. We've known that, for instance, that there's a gender imbalance in physics that goes on a long way, and it hasn't really changed in this country for very long. But actually looking into that in more detail, there's a brilliant paper by Louise Archer. I mean, it's part of a series, but I particularly like this one, that kind of shows that physics really does, in the minds of school kids, they think you have to be clever. They think if you're not white, you're probably not going to be accepted in there. You know, we talked about the gender imbalance, social class as well. These are massive factors about whether people even want to continue studying with physics at all. And really all that's going to do is inequitably dissuade students, even those that really actually like the subject and could thrive in it, from wanting to continue it. And that's not okay. So Louise Archer and collaborators, they came up with 3 sort of areas, particularly in school, that seem to be causing some of these issues, right? The first, there's an issue of gatekeeping. Particularly, they're talking about, I think at GCSE, like whether people are even given the option to continuing. So, you know, we talk about this issue of the attainment gap and whether you're doing double science or separate science, and that might have already set in place whether you could even try and do physics at A level or even degree. So that's not great, this sort of gatekeeping in schools. There's an issue with the curriculum as well, in 2 separate areas. So, you know, the curriculum, obviously we have to kind of evolve our models, but it seems that teaching is the way it's taught in physics is oversimplifications that kids just see as lies when they come to the later evolvements. It doesn't seem to be presented in the way that we know scientific models work. That concept is not being get across, so they just think their teachers are lying to them, which is not a great thing for kids to think. And then particularly, there's this sort of deferment of the interesting or the real physics. They think that basically that school physics is the stuff that was done hundreds of years ago, and they're not getting a flavour of what current physics is like, what it's like to be a physicist, or you know what's the interesting, cool stuff now. It's not really in the curriculum, and that kind of makes physics a sort of a perseverance battle. Can you hold out for the interesting stuff and get through all the boring stuff, which is really a shame, you know, for people that have taken physics further. And I can relate to that. I thought physics A level was pretty boring, to be honest, but I knew there was more interesting stuff to come, and I stuck with it. And I think Louise puts it really well here. I don't necessarily entirely agree with the statement, but she says, there's currently little reason to assume that commonly existing interventions, which are based on individualized approaches to infusing, inspiring, and informing students about physics, are likely to lead to any significant changes of the numbers or profile of those participating in post-compulsory physics. Such approaches do not fundamentally address some of the important school-based processes and practices which play a key role in producing uneven and low patterns in physics participation, and so are unlikely to have a significant impact on participation. So, I mean, it's a bit dreary. She's saying that outreach isn't going to do anything, and I don't completely agree with that, but I think there's something to take away with that we need to actually be addressing in the interventions we do some of these challenges and problems that we face with physics as a field, but also all the societal factors to do with STEM and the science capital. So that is the really uplifting start to this talk, and let's actually talk about trying to move on from this. So evolving STEM engagement to address some of these problems. And you know, we've seen quite a lot of work in this already, actually. I did a Google search for science capital and engagement, and these are just some of the organizations that turned up on the first couple of pages. So these are people that work with in science engagement, particularly with young people, and that are adopting the results of the science capital research to do more effective engagement. So that is fantastic to see that we've got leading organizations taking on board the research and really trying to make a difference. So yes, we're becoming aware of those issues, but actually, what are we trying to do about them? And actually, this is where I want to ask another question, because I want to get a flavor of the sorts of engagement that you're currently doing in the setting of schools. Obviously, engagement, we said, can be much wider, and obviously we should do more than just with schools, but in the case of schools, how long do your engagements last? You know, any particular student, how long do you actually interact with them in the work that you do? That could be, you know, if a stall or a stand, you know, a careers fair or something, that's only going to be minutes. If you give lectures or a workshop at a school, you know, that's probably going to be on the order of an hour or so. You might have events on campus that last for, say, a day, like a masterclass. or week-long things like a summer school, or you might be doing some of these sort of deeper programs that last over months with many series of interventions. I just want you to click all of the types, all of the lengths that you typically do with schools, and remember, in the context of your role. So Ollie, if you wouldn't mind launching that poll, we'll see the results come in.
Martin, I realise as well, this poll allows you to select one option. So the participants might not be able to select multiple options. Apologies.
Do the one that you do the most then. What's the typical outreach you do with schools? So we're getting, on the researcher side, fairly even split at the moment: minutes, hours, days. Professionals, minutes, hours. Just give it a bit more time. Okay, I think we should probably finish that up there. Ollie, do you want to share the results? Okay, so as we can see, you know, really we're only interacting with students on the order of minutes, maybe up to days, but particularly maybe an hour. So I'm guessing that's a workshop or a lecture seems to be the thing that we're most often doing. Okay, so the reason I asked you that is I want you to kind of critically consider how much influence you really have on a young person when you only see them for an hour. And actually there's this really interesting idea that was first come about by Brofenbrenner in, I think, 1979. It's cropping on my screen a little bit. This idea of a learning ecology, right? We don't exist in isolation. Our interventions come as part of a whole wider world that the students kind of interact with all the time. And there's this sort of diagram here that can kind of conceptualize that. So you have a young person in the middle, and they have their microsystem, the people that they see day to day that will influence them. So yes, their family, their peers, you know, their teachers and the school environment, neighborhood, stuff like that. You know, there's a wider system that, if we go further out, like the exosystem, there are people that they don't really interact with very much, but obviously have some sense sets the environment within which they are, like their school board, or their parents' economic situation, you know, the mass media, things like that. So they have less direct influence on that young person, but they obviously contribute in some way. And you basically, with this diagram, as you go further and further out radially, you're decreasing the level of influence you really have on that particular individual. And so, you know, bearing that in mind, and the idea that aspirations are so tied to identity and they're multifaceted, it's not surprising that actually, you know, if we only see a kid for an hour, are really going to fundamentally change whether they think science is for them or not? No, it's, you know, in the grand scope of this ecosystem, that we're a drop in the ocean. So is there something that we can do to be better at that? And there are two sort of complementary approaches that people are starting to take, bearing this in mind. The first one is repeated interventions. So we can say an individual scientist or engagement professional might sit somewhere in the exosystem or the macrosystem. So, you know, fairly far out here. Can we move ourselves closer in by actually spending more time with a particular group of students that are in need of these interventions to allow them to fulfill their potential? That's the idea behind repeated interventions, just upping that interaction time so that we become more influential. And the other complementary approach is influencing the ecology, or influencing the influences. So can we not just focus on the young person, but can we also try and interact with the family, with their peers, and with their schools, so their teaching, affecting their practice, which is then in turn going to affect the young person. Those two seem like ways of being more effective with engagement and really having impact. And so I brought together a whole load of people over this past year to kind of do a bit of a review of these types of programs that are emerging, that are doing these different approaches, and what it looks like the potential impacts of these different approaches can be. So, you know, one-offs obviously do have value, there are things that they can do, but they typically seem to just focus on the young person. And, you know, the young person might learn some factoids, which, you know, about physics or science. They might become more aware about careers. It might support an existing interest, but, you know, the evidence doesn't seem to be there that it's helping raise or maintain STEM aspirations in any measurable sense. So the next thing you might do is go to a short series. So what if I do 3 interventions over the course of a few months, for instance? This sort of approach at the moment seems to still only really be considering the young person. And, you know, it does have some more impacts than a one-off, right? So, you know, even more awareness of careers and supporting interests, but also changing perceptions about scientists, increasing confidence. But at the moment, again, the evidence doesn't seem to be there that it makes a difference with aspirations. However, there are deeper programs that, you know, may occur over a similar sort of timescale as these short series. So over the course of a few months, but by interacting not only with the young person, but trying to influence teachers and family, they seem to have more effective impacts on things like confidence and skills development, some evidence of attainment, some evidence of affecting aspirations, and some emerging evidence that in fact it can also affect the destinations in terms of career choices or degree choices in longitudinal studies. If you want to learn a bit more about all of the different programs I've sort of drawn from, there is this preprint of the paper that you can have a look with, and we'll be sharing the slides afterwards. So it seems these deeper approaches do really seem to work. So the theory checks out in practice. But of course, I don't think there is one single program that can solve all of the issues, right? We saw in the STEM pipeline that there's issues at the beginning, there's issues in the middle, and there's issues at the end. And this paper from Carol Davenport this year and her team at New STEM, they show one way of potentially parameterizing the sorts of messaging, aims, and goals of our engagements and how those need to actually evolve throughout the trajectory of a kid's educational journey, starting from very early on, allowing experiential learning, going on to careers-inspired and curriculum-linked activities in primary, being more focused on careers perhaps in secondary school to show the value of STEM, and then once you've got them sort of hooked and aspiring towards STEM subjects, maintaining and sustaining that interest so that they actually end up going to university, which raises a different issue. So again, I've got another poll on this. You know, think about your role as either a researcher or an engagement professional. Out of these, explore, acquire, aspire, and sustain. Which do you think you would actually feel the most confident in delivering as part of your regular engagement? Have a think about that, and Ollie's going to launch the poll.
Results are coming in more slowly, so people are obviously pondering a little bit more.
Yes, this one's a bit more difficult. This is a bit more difficult. And I imagine we might get a bit of a split because people will have different opinions. And of course, this is not the only way to characterize it, but I think it's a nice way to start thinking about how we need to change the messaging as a kid grows older and what they actually need.
I'll share the results in a minute, but it's quite interesting, the split that are coming through actually. Here we go. I think we're almost there.
Okay, yeah, let's have a look.
That and share that now.
Right, interesting.
So fairly even, and yeah, different according to professional versus researcher as well.
Which is exactly why we started splitting these results out by the roles, because I thought it would be different. But yeah, so fairly split actually. That's interesting. Yeah. So I personally thought that perhaps we might see researchers a bit more skewed towards the sustain sort of end, and that was based on a Charlotte Thorley's PhD thesis, which looked at the motivations of physics researchers in doing outreach, and it found that, you know, actually they felt that their role as a researcher and the research they were doing was the most important thing that they could deliver. But a lot of the other sort of messaging along this path they thought were important, but they didn't really think that their role was as important. But I guess, you know, we've got a slight selection bias here. We've got a load of people that are really into engagement because you're at an engagement seminar. And so some of you are probably more keyed into doing those earlier stage stuff as well. So that's interesting. Cool. Thanks a lot. Right, so I'm going to now move on to the PRiSE approach, and that was really sort of stemmed from this idea that there's value in the research being embedded into our engagements, in a sense being able to sustain and raise aspirations, particularly towards physics, and potentially even confirm subject choices and affect destinations. And so I think there's really a spectrum of how embedded your research can be in an engagement activity. And depending on the age groups and stuff that you're working with, obviously there are different approaches suit different audiences and needs. But I would sort of characterize it like so. This is sort of built on some of the ways that actually CETNet have been reporting this stuff, and based on conversations with some of the educational researchers. So some physics outreach has been very, very curriculum based, and that used to be the case. Or, a lot of it used to be that way. I mean, maybe sort of 10 years ago, we were just supporting the curriculum for teachers. Obviously, you can talk about research in a one-way type fashion, so that might be a lecture. If you incorporate aspects of your own research into a lecture, you've got a one-way engagement, but it does have a real research base in there, so that has inherent value to it. Some of you might be coming up with two-way engagements that have inspiration from the research. You might have developed your own activities that are based in the research you do or that in your department does. They're great as well. And you can't really go much further than actually getting students to be collaborators with you in your research. So I've got one final poll question to consider. Where do you think most of your activities lie on this spectrum? Are you red, orange, green, or blue in terms of how much research are you really pouring into the engagement work that you do? And this is going to be interesting. So it seems on the professional side, we're getting a lot of two-way engagements inspired by research. We've got one person who's on the research side, students as collaborators. I wonder if that's Chris, or I mean, there are other people in Oxford I know that have been doing great work like that. I think we might be fairly split again on this one. Need a larger sample size for some good stats. Okay, I think we can share the results now, Ollie. So so the professionals coming up with two-way engagements. We know that's the great way of getting them engaged and inspired by the research. And then on the research side, it's almost a bimodal distribution, even though it's very small sample sizes. So either that sort of one-way, lecture style, I guess, or full-blown. Let's get students collaborating in the actual research. So that's interesting. That's cool to see. We need a diversity of approaches, and we're seeing that there. Great. So when we were developing PRiSE, we were really aiming to be blue. We were aiming to be that. Can we really give a flavor of what real research is to students in a way that might be beneficial to them? And so, physics research in school environments was born, PRiSE, and kind of describe it as a scalable framework for accessible 6-month-long independent research projects for schools based in real cutting-edge physics research and mentored by active researchers. So it's important that it's supported. The scalability is about trying to balance that level of support, but also reach, because we know we're driven by, we want to reach big numbers, but we also want to have an impact. So can we find a balance there? And I think PRiSE finds a nice little balance in that. But really, it's just a way of working, right? We developed so far 4 projects. They're all incredibly different areas of current physics research, different approaches to actually doing projects. So the first one was actually based on a cosmic ray detector, very similar to the photomultiplier tubes and scintillation that goes on in deep underground neutrino experiments, and the cosmic rays are actually a calibration source. So we started off doing very equipment-based stuff, but equipment's expensive. That's not very scalable. So actually all of the other ones have been more based in data. So My research area is in Earth's magnetosphere, particularly in the dynamics and waves that are present. And I thought one accessible way of exploring data is, rather than looking at wiggly lines, is actually listening to it. So converting that into sound and seeing if we can find stuff in the data using the amazing pattern recognition that is between our two ears to find stuff that standard techniques might be missing. We also did some stuff about the coding agenda, learning Python and applying that to Kepler and later test data. So we can get a sense on how scientists do research by doing coding, writing algorithms, which will then detect stuff in the data and find exoplanets, for instance. And then later using some tools from the Atlas detector at CERN to show about, you know, the statistical processes behind particle detection and why particle physics isn't quite as easy as just drawing a Feynman diagram and just looking for the right particles, that particle physicists need to play dice. And Atlas had made a great tool for undergraduates to play around with this, and we simply adapted that with the level of support and guidance that we gave to work with secondary and sixth form students on that. So they're really different projects, but the thing they share in common is the ethos behind them. And I want to introduce you, some of you may be aware of this idea of a theory of change, but I really think that it's an important way of considering any sort of activity or program that you might be developing, because what it does is it provides you a pathway from the single intervention or series of interventions that you might be doing and how that might potentially lead to some real long-term impact. And the idea is you start with what you want to achieve, that impact right at the bottom here. So in the case of PRiSE, we want to contribute towards increasing the uptake and diversity of physics at higher education, linked with as well, making the schools that we work with environments that will actually support and nourish all of their students' science capital. Those are the real goals that we want. And essentially what you do is you work backwards. What steps do I need to do to get there? And that should inform how you develop a program and how you approach things. And really, I'm not going to go into details about this diagram because it's horrendously complicated. And that's not surprising, given that we saw that aspirations are horrendously complicated things. But wherever possible, all of these arrows that you draw from the short term to the medium to the long term and to the impact should really try and be based on evidence. So I've tried wherever possible to find papers that suggest that this is the right approach to take. If you want a full discussion of that, one of the papers about PRiSE is in open peer review, and again, you'll be able to have a look at that. But I think it's a really useful way in terms of whatever you do to think about that when you want to develop any sort of outreach or engagement work. But really the ethos behind PRiSE, it's kind of a three-stage program. There are lots of different interventions and methods of support, which I won't go into detail here, but I think you can sort of you break it down into three areas. So you start a project and you want the students to just build their confidence. You know, they need to think about, well, what is this topic of physics research? You know, a lot of areas of physics research are not covered in the curriculum. They obviously have links to some of the more fundamental physics that they cover in the curriculum, but they really aren't aware that it's going on. So they need to be able to kind of explore this new area that you're giving them access to, find out how research works, and get a sense of something that they can actually do, some steps that they can take. And so, you know, from your side of developing a project, for instance, yes, you're providing introductory materials, you're providing probing exercises, and you're giving them those first steps that they can take to build that confidence. So once they become a little bit more confident, what PRiSE then really aims to do is to allow students to gain independence in that area. So allowing them to try things out, explore within the topic, and that comes within that way that you design a project, that you can go different paths and just have a go, play about, just like we do sometimes day to day when we're first attacking a problem. And but also giving them that sense that they're not wandering in the dark. You know, are they on the right track? And so really what, again, we're providing is flexibility to explore, example ideas, because it can be a bit daunting. We say, and now you can do anything. But also you're providing your expertise, because we have this built up knowledge that we just know. And it's really valuable in that mentoring relationship to provide that expertise to nurture and guide a student to allow them to play and get along. And then at the end of the process, obviously, we want them to complete something that feels like a piece of research. So they can reflect on what they've done, think about how they share their work, for instance, like at a conference, posters, talks, things like that. That's what we do in PRiSE. And to help them with that kind of end parts, providing them with good practice guides. And again, your expertise, giving them comments, just treating them like a collaborator is the way to go. And now the different projects that we have different levels of that in that spectrum of how really embedded it is. Some of them very much, the current research is embedded, and some of it's slightly more inspired. But I think those three stages that we took in the ethos of PRiSE projects really holds throughout. And now I just want to quickly whiz through some sort of highlight results from the program that I won't go into a huge amount of detail. But firstly, I want to talk about the schools that we work with. As I said before, we're trying to balance reach and significance. We want to work with as many schools as we really have capacity to do, but we also want to make sure that we're not setting them up to fail, that we are providing them with enough support to both the students and their teachers as well, that they can succeed and they are going to get impact from it and a real sense and feeling of achievement. And that's a hard thing to balance, but by taking this approach and growing the program slowly since it was started in 2015, we've built up eventually to 67 schools, 88 teachers, and over 1,300 students, which I think is a good number. It's a good number given the practicalities we've got here. But it's interesting when we look at the schools in the targeting and the support that we give to schools, that actually we're getting more diversity than is typical for other sorts of programs of independent research projects. I think it's really important that not only do we design these things right, that we make sure they're reaching the right people, that we're not just serving the people that, it might have some impact on them, but there are others that need it more. So we've got to have that diversity to address some of those societal issues. And also to make sure that the approach that we've taken and all of those interventions and support are actually allowing the kids to succeed. And it seems, as well as that diversity and PRiSE, success in the program, as far as we can tell so far, is independent of the background factors that we know affect uptake of STEM. So that's really positive, and something that hasn't really been looked into in much detail. And I think it's something the whole engagement sector needs to be considering a lot more. This data on the equitability of engagement programs. Let's talk a little bit about impact. We actually assess impact on the students at two different stages. So at the end of the 6 months, we've got evidence of increased confidence in STEM practices and topics, which is nice to see, aligns with some of the stuff I was talking about earlier. Skills development, which obviously is a time-consuming process, but I think that these sorts of projects really do allow for that, the skills development, because they're really accessing stuff and playing around with stuff that they wouldn't have access to in their ordinary school environments. And there's emerging evidence from this year, because it was hard to kind of design the evaluations quite right and make sure it was quite appropriate, that it can have an influence on aspirations. And the one thing you're not seeing in this particular graph that I'm showing is that we started out with students that didn't seem to be particularly biased towards physics, and yet they are feeling more likely to want to pursue physics going on. We've also done some longitudinal evaluation. That's even harder than that 6-month stage evaluation. So sample sizes are small, but there's some really good emerging evidence that not only does it seem like we're getting an uptake from PRiSE students in pursuing physics or even just STEM more broadly, but actually by being involved in this sort of two-way process over the course of 6 months between the university and the school, that this has been a lasting and beneficial experience for them. And these are just a couple of quotes, but we've got loads more of them in the paper on impact that really show that this does feel robust in a qualitative sense. And then, of course, I talked about influencing the influencers. The key one is by using teachers as our go-to and helping them evolve their practice as well. We've gotten from the teachers, without any a priori assumptions, that they're learning new physics, they themselves are developing skills, are developing their mentoring, they become more comfortable with research. They are using this not only in the projects, but in their wider lessons. They are championing their students across the school and potentially also raising the entire profile of science in their schools and developing a long-term relationship with the university. Those are things that came out from the comments from teachers that we're now able to better quantify. It seems to be really quite impactful on teachers, and like I said before, influencing the influence is probably even more important than influencing the young person individually, because they just have so much more effect on a wider cohort of students in a very long-term sense as well. But don't forget ourselves. This is something that we haven't looked into in so much detail just yet, but I think that there can be impact on the researchers. We want mutual benefit. The NCCPE describes public engagement as, to engagement for mutual benefit. So we don't want to just benefit society. There should be something that we get out of it as well. Otherwise, why are we doing this? And so I will highlight that we can get research results out from this approach. We've got one paper that got a bit of media attention, highlighted by the editor, some other promising preliminary results based in one of the projects. It really depends on how much work you put in, though, into the design of the project, whether you're going to get that out. But I think even if you do take the approach that we've taken with some of the other projects, which is not reinventing the wheel and just adapting materials that we already had into an accessible way for schools, that actually can play a big role in researcher development. And so if you're able to take this approach and sort of embed it within your research groups, getting lots of PhD students involved, for instance, not only does that spread the load, but it's going to help develop them as researchers. So that's really all I want to talk about. I've kind of whistle-stop tour of the landscape of STEM in schools, talking about science capital and aspirations and the pipeline of STEM and physics. Talked a little bit about how STEM engagement is perhaps evolving and how we can think about repeat interventions and influencing the learning ecology rather than just thinking about young people. And also how we need to think about different messages at different stages of the educational journey. And then I've given you a little bit of an intro to the PRiSE framework that I developed and how that seems to have some long-term impacts. So thanks a lot, and I'm sure that there are some questions. So I will stop sharing my screen and let's have a bit of a discussion.
Martin, thank you so much. That was really informative. I can see the rounds of applause coming up virtually and through clapping on the screen. Thank you for sharing your work there on that. I think what's so nice about the PRiSE programme is that there could possibly be a perception that involving students so directly in research work is too hard, I suppose, in terms of the content of the research work, and then also in terms of organising something like that logistically. But you've kind of shone a light on how actually it can be done and can have benefits, not only for the students, but also then for the teachers and the practitioners as well, and the researchers. So I think it's a really interesting project and an interesting framework to work from. So thank you so much for sharing that. I can see some questions coming through in the chat, and if people feel happy asking them directly, I'll invite you one at a time to come through with that. Catherine, you were first, so I'll let you take the lead if you're happy to, and ask your question to Martin.
Oh, thank you. It's a fairly simple question, really. How do you assess a student's aspiration? What does that mean to the student?
Yeah, so I mean, I think there's different ways of doing that. I mean, the way that we did it was quite simple. Was, how likely do you think will you continue with physics? How likely will you continue with STEM? And kind of, so you can do that on a sort of an absolute scale. So like from not very likely, unlikely, neither unlikely, that sort of Likert type scale. Before and after. So that's one result I didn't show. But also, I think we always need to show some level of aspiration. Attribution. So actually getting them to reflect on whether that's changed. That'll give you a different result, but I think together that gives you an overall sense. And the other, there are other ways of looking at it rather so directly than do you want to continue doing this subject? And you can probably draw from the Aspires report and some of the questioning that they use there. But it depends on your aims and particularly how in-depth and how robust a number do you really want to get, or do you just want to give a sense of the impact it's giving?
Thank you, Martin. If everyone's happy, I'm going to hit these in chronological order. It seems the fairest way of doing them. So, Katerina, if you're free, I notice you've got a question about teachers.
Hi, Martin. Can you hear me?
Yes, I can.
Yeah. Sorry if this is a slightly unfair question, because I know it's not really the focus of your project, but actually one of the things that you mentioned right at the beginning grabbed my attention, was this idea of the teachers as gatekeepers. And I'm assuming that, so I come from a different educational system where I think teachers probably don't have quite the same power, maybe, let us say, as in the UK in influencing which choices the students make. But I was just very interested if you know of any research that's been done specifically on teachers to try to understand what biases their views of what makes a particular student more or less suitable for a particular subject.
Yeah, so I mean, I think there were two sort of areas of that gatekeeping. One of them very much was like the school decisions on who gets to do the subject based, you know, purely on attainment. But there is the other one that you raise as well, which is the sort of the biases which teachers can have even unconsciously about giving bad advice to students. I think that's something that people have looked at. I would first look at that paper from Louise Archer et al. And go down the rabbit hole from there. But I think it's something that probably even prompts more research to, you know, where are these things coming from, and how can we best make sure that that we're not giving kids bad advice and sending them down a path, you know, when they would have been perfectly capable to go down the path that they originally wanted to. It's a really important point.
Thank you, Katerina. Thank you, Martin. On to Grant now. Question around scaling.
Hi, Martin. Thanks for that. I think you made some really strong arguments about how more depth can be much more effective in this kind of thing. Obviously, the question then is about, once you've shown that, like, how does this scale? So assuming we can just bring in more funding to do more of the exact same stuff, like how do we trick this? How do we beat that system, and how do we scale this kind of thing? What are the next steps?
Yeah, so I think we were always kind of competing with that reach and significance type thing. And we found that, you know, PRiSE basically has like 3 intervention stages. And so, you know, if you've got a single person, that means that over the course of 6 months, you could probably support, you know, maybe 10 schools, because it just comes at very specific points. And actually, you know, the move to online engagement, where you know, actually I've done very little online engagement since lockdown, but I was doing more before, because actually just having something like a Zoom open where students and teachers can drop in if they want to ask questions, that's quite easy to do. And so that can provide a support mechanism as well. But I just think, yeah, embedding that within the research group so you have more people to draw upon. And then if they're, you know, only having to do 3 things a year, I think that's a sort of manageable balance. And if we get more universities on board with kind of dealing with their own local areas, because we can't individually do this sort of thing nationally, but together, collaboratively, we probably could.
Okay, collaboration's the key. Thank you, Grant. Thank you, Martin. Question in for Amory, who I don't recognise. Your appearance has changed. Come in disguise.
I'm afraid my hair has reversed. It's disappeared from the top of my head and appeared on my chin. Hi, Ollie. Hi, Martin. How do students come to find themselves enrolled on PRiSE? I mean, is this just advertised within your target schools? Are they suggested by teachers?
Yeah, so, you know, we give the teachers the sort of power to better understand their school rather than imposing anything. So yeah, I think by involving teachers at all stages in signing up, in the support, and at the end stages, that's the approach we've sort of taken. So, you know, we provide things to teachers to make that helpful. So, you know, like posters and things like that, all the information that you need. But we really when we provide recommendations, but obviously the teachers are more experts of what their school is like than we are.
Yeah.
So sort of leave it up to them.
But they're I mean, they are basically recruiting students. It's the teachers who are basically recruiting students for this project.
Yeah, I mean, encouraging them if they want to do it. You know, for instance, we might have the initial session might be as part of a regular class. And then we sort of we don't force anyone to do it. It's an opportunity if they want, and we were just there to encourage and support. So I think that is the right approach to take, because, people talk about a captive audience, but captives. And so that's not a great sense. And again, that's something that came out of Charlotte Thorley's research, is that when people feel like that they want to be there, that they have had a degree of choice in being there, then it's just better for everyone.
Yeah. So how does this compare with the Nuffield research placements?
Well, I guess Nuffield is more intensive, and each individual researcher gets and works with only one student.
Yeah.
So we're trying to broaden the net, I guess, in a way that will still have impact. And that does have impact, but doesn't make it like you're cherry picking students.
Yeah, I mean, I haven't done any of these Nuffield research placements, but I know people who have done them, both participants and researchers, and I find it's something of a self-selecting group who applies for this. PRiSE looks far more broad to me. That's
the approach that we're trying to take. If we can empower them to do this, then hopefully we're not so self-selecting. It's really hard to show that concretely. Like, we've got some evidence that, like I said, that there doesn't seem to be a previous bias, and that they were dead set keen on physics from the outset. But if you want to do that really robustly, I still haven't worked out how you could even think about randomized controlled trials, given that we give so much power to the teacher. It's not really the same as getting a student to individually apply to something. So that's research for someone else to do, I guess.
Thank you very much.
Cool, thank you. Over to Chris. Question about real research.
Yeah, thanks for the talk, which distracted me from the first 5 minutes spent wondering how proud of my face I should be. So thanks, Ollie, for that. But yeah, no, it's wonderful stuff. I wanted to link an idea you introduced early on, which is this idea that school physics is a lie, right? Because it doesn't turn into the real explanations or the real science, with how you frame this program. Because there's obviously a lot of weight on this being real research, right? Or at least has the aspiration of being real research. And yet we see and expect that most projects aren't going to produce an output. And that, I'm not saying they should do, but I wondered how you frame that with the participants, so that they understand, so that you keep the excitement of this being real, but they understand that they're not going to discover phosphine on Venus or whatever else.
Yeah, I mean, it's a challenge. I think in the development of the projects, we've always tried to, what is the one element that we can make the most accessible about the research, and sort of hone in on that. What is the thing that we can link to the ideas that they're already familiar with, without over inundating them with extraneous facts that go around it, that we might introduce later once they've built their confidence a bit more. I think, you've got to put a bit of thought into your own research area and what you think the right hook is to go down that path. But also from the outset, very rightly, like you say, we do sort of manage expectations, and particularly we're trying to give them an experience of what doing research is like, and that research isn't easy, right? You can't just look at the answer in the back of a textbook. And so we lay out this support process that, look, you're going to get stuck, because I get stuck all the time, but these are the steps you can go. You can talk to we get them to work in groups, talk to your classmates, groups, maybe together you can come up with an idea, then go to your teacher if it's still not working. The teacher is there to provide encouragement and whatever support they can. And if it doesn't amount to solving the next hurdle, then they will get in touch with us. And then I always say that if we don't immediately know the answer, then we found something really interesting and we can try at it. But I think that the students are totally fine with not, they're not looking to get a paper out of this. Half of them don't even know what a paper is, right? They don't know that step, but they're all able to do something that feels like it's complete. Like that they started a thing, they went down a path, and then they were able to produce a result through the support we give them. And that in itself still has value. The fact that we've had some actual research results come out and being able to share that widely across the schools and telling them that's just further reinforced students to say that, oh, actually, this is something that I could do. But I haven't really seen any real negatives because of, I guess, maybe because of that approach that we've taken. Hopefully that answers your question.
Yeah, I think so. I mean, it's the real lies in the method and the experience rather than the question or the answer is what I got from that.
Yeah,
and
exactly.
I think that's true of a lot of the citizen scientists as well. They want it to be real on Zooniverse. They want it to be real. They want it to have the potential for discovery, but they're actually, to a large extent, not motivated by their name on a paper or even their discovery necessarily.
Yeah.
Thank you, Chris. Thanks, Martin. Martin, if I can jump in, because you mentioned there about completion and the importance of that and then getting something tangible within that. And I know that can be quite challenging when you're dealing with time limitations of an academic student school time, and as well as, you know, other research commitments. How critical is that completion part, and how do you ensure that happens within the timeframes of the school program?
Yeah, I think when you create the sort of resources for this sort of stuff, we think about, okay, you know, they're probably going to get through the prescribed stage, so the initial steps that we give them. So when we then present options of things that they could do, which they don't have to take, but we present options, we think, okay, well, what's the low effort thing? What's the medium effort thing? What's the high effort thing? And then when when you meet the students and you're discussing what approach they might take, what path they want to go down beyond that initial stage, you can sort of guide them based on how much and how fully they've engaged with that to provide something that's sort of realistic within the time frame. And then again, you know, providing the comments along the way and setting that context. I think it's totally doable if you just have in mind a few things that would be like, okay, once they've done that, it's only a couple of calculations and they'll have that and that will feel complete. But if they wanted to go more, maybe they'd go down this direction. Just thinking about those sorts of options and providing guidance at the right stages.
Okay, I see. So a kind of tiered approach, almost different levels of wins. Okay.
But also always have the option that they can do whatever the hell they like.
Okay.
And that's where your expertise comes in, because it's only you can know if that's a sensible idea or not.
Yeah. Thank you, Martin. We have got a few minutes left. We've maybe got time for one more question within the 1 hour. I can see some people have had to disappear already. So Catherine, I'll hand this question over. Martin, before I pass over to Catherine, you mentioned you are able to stay around a little bit longer if some further questions come in. Is that okay? But for those of you who need to go sharp at 1, thank you so much for joining us. And the next seminar again is with Jen DeWitt at the end of the month on the 30th. I'll send around reminders of that, so please do join us. But thank you so much for joining in and participating. Your questions have all been great. But those of you who are able to stick around, please do. Martin will be available to answer a few more questions. So thank you for that, Martin. Catherine, you say you've got another question.
Yeah, sorry. So at the beginning of your talk, you were talking about realizing aspirations in the sense of these kids aspire to science or physics or whatever it is, but don't necessarily like follow through on that. I was wondering if you've looked at all at that question in the context of PRiSE.
Well, I mean, yeah, that's a good question. I mean, all we have really at this stage is the results from 6 months and the results from 3 years later, which show that there's at least a maintaining, if not raising, of aspirations, and then that seems to follow through that students become more likely to undertake a physics degree or a STEM degree than you would otherwise expect. But we can't link individuals, and because we're sampling different data, different cohorts, because of the practicalities of trying to do this, this isn't this isn't a well-funded educational longitudinal study like Aspires is. So there's an indication that step, that drop-off isn't occurring with PRiSE students, though I can't really tell you any more than that. And I don't think even just the understanding of where that drop-off in aspirations to destinations actually comes from. I think that's something that the Aspires team will probably be working on in part 3 of their project. But I think it's an area that we need to look at more.
Thank you, Catherine. Thank you, Martin. I just wanted to pick up on Chris's comment and echo that. Their future seminars are open, so if you have any topics that you would like us to explore, or recommendations for speakers, or indeed if you would like to speak yourself, please do let us know. I have a couple more seminars lined up in the pipeline. I'll announce those when they get confirmed, but please do. It'd be great if we had further areas, because I think these seminars are most useful if they are by and for you, us as a community. So make them around what you want them to be interested in. Not to take away from you, Martin, the focus is still on you right now, but Martin, again, if you've got any recommendations for future people to bring in, let us know. It'd be great. Any further questions? Anyone else got anything they'd like to ask about at this stage? No. I'm getting smiles. Oh, Catherine, keen bean, go for it.
Questions.
Sorry, here we go. Have you found that the research in school stuff, are they mostly year 12 students doing it?
That's that does tend to be what the teachers go for. Like I said, we provide the recommendations that we you know, that at A level anyone should be able to do these. At GCSE, you know, I'd probably get them to select it a bit more. We have had the case of even a year 9 student do it who did fantastically actually. But yeah, it tends to be just because of the level of material and time constraints. It tends to focus on that year 12. But of course, like I say, you know, research in schools is not the be all and end all of everything. You know, so when I was at Queen Mary, you know, we'd have other programs to deal with other ages that dealt with different approaches, because there is no one program that's going to solve the issue of uptake and diversity at STEM. We've got to do lots of different things at different stages of the children's educational journey. So yeah, the PRiSE is more of a fit near the end, but there are other things that can and should be done earlier on. That's not to say that's all on universities or engagement professionals in universities, right? Remember that there's a whole other world of science communication and engagement from museums and freelancers and community groups and all that sort of stuff. So if we were, you know, ideally we need to start working more collaboratively even across sectors and working out who does what, how we slice up the pie to make sure that we're not interfering with one another, and we're working in the most effective way. But I'm not the person to sort all that out. That's way beyond my pay grade.
Do you find the students tie it in with anything like an EPQ or like school coursework or anything that they get an academic credit for, or is this genuinely just something they kind of do on the side?
They can do. I mean, I think it's down to whether teachers are aware of these things, have capacity to support those specific activities. Often we find that most students probably don't go down that route because they actually feel like the presentation at a conference is in enough of itself a worthwhile thing. They don't necessarily need it for the academic credits. I'm sure they write about it in their personal statements at university applications, and they talk about it endlessly because we see that they are beneficial experiences, things that have lasted with them that they've gone on to use or talk about subsequently, but not necessarily in gaining a qualification around. But that, you know, that option is always open. We just don't kind of enforce that or try and make that happen. Let them do what they want.